So let's start the order of reaction and all. Let me know if you are not able to solve this. 17 is very easy and 18 is also easy. First order reaction rate constant K is given. The time required for 40 gram of this reaction reactant to reduce to 10 gram will be. Any answer? For this, any answer? Shahid? So basically, see this question number 16 is very easy. The rate of reaction depends upon. Rate of reaction is equal to change in concentration upon time. Change in, there is no volume. So it is concentration of reactant, it depends. For this, the rate constant is given. Okay. And the time required for 40 gram of the this reactant to reduce 10 gram will be. So I gave you a formula. K is equal to 2.303 upon T log of initial concentration R naught upon final concentration R. So T will be equal to 2.303 upon K. K has a value 2.303 into 10 raised to the power minus 3 into log of initial concentration is 40 and final concentration it should become 10. So log 4 we get, and this will be cancelled. When you are going to move this up, you will be getting 10 raised to the power 3. And here log 4 can be written as log 2 raised to the power 2. And 2 will be here. And it becomes 10 raised to the power 3000 into 2 log 2. You know the value of log 2 is 0.30. Is 0.30. So what it will be 0.3, 0.6 it becomes. So 1000 into 0.60. And when you are going to multiply it, you will be getting 600 seconds approximately. Basically, the log 2 value is 0.3010. Okay. So when you are going to multiply it, you will get 6020 something, and you will be getting 602 seconds. And according to that, the answer you can see is what? A option. Is that clear? Shahid,
Yes, sir.
please do write it. Let me know when you are done with this. Can you change the slide? Shahid,
Yes, sir.
please do it. Let me know when you are done with this. No, it's not. See, for zero order reaction, T half is equal to R naught upon 2K. Now, what you are going to do, T half, when then is the half life period, T half dash will be equal to double of this, right? Concentration is going to be double, and this is the value of T half. So the new T half will be double of the previous T half. Yes or no?
Yes,
This
sir.
is for zero order reaction. You'll be able to solve this question number 20.
No, sir.
Yes or no? Or you can reply in chat box. Okay, see, I'm going to explain. This type of question, first of all, this is your fast, this is your slow, this is fast. Always remember that the slow state is your rate determining state. And according to this, if you are going to write the rate will be equal to K into, and this rate law expression is expressed in terms of a reactant. So it will be X into Y2, X into Y2. Now you will look at the main reaction. Now you will look at the main reaction x2 plus y2 into 2xy, in which y2 is there but x2 is not there in this. Y2 is present in this rate but x2 is not there. So you are going to find out from this first equation the first and second in which x is present. We don't need y2. Sorry, we don't need to find y2 because y2 is present in the main reaction. We need x2. So you can see x2 is present in the first reaction and there is no x2 in the last reaction. So I'm going to write for this x2. This reaction can be written as x2 is giving you 2x, x plus x, that is 2x. And I'm going to write K equilibrium for this. K equilibrium is equal to product upon reactant. Product is x and raised to the power 2 upon reactant is your what? The reactant is x2. Now I can write
Sir,
this since
why
we
x to
need
the
to, what did you say?
x? Why x to the power 2?
KC, if you have studied in class 11th, K equilibrium, KC, KP, whatever is that, basic equilibrium constant when we study, whatever is the stoichiometric coefficient. Here it is written x plus x. So that I wrote 2x.
Okay,
So whatever
okay.
is the, here stoichiometric coefficient is 1, so the power is 1. Okay. And we need to put the value of x in terms of x2. So I can write x whole square will be equal to K equilibrium x2. And then I can write x will be equal to K equilibrium raised to the power half and x2 raised to the power half. Can I write it? Tell me.
Yes, sir. Very nice.
Wait a minute. Can I write this? X2 raised to the power half.
Yes, sir.
Now this x value of x I'm going to write it here. So see what happens here. The rate, we need to calculate the order. So this is how you're going to do. The rate will be equal to K into, and x can be replaced with K equilibrium raised to the power half. This is the value of x. X has a value K equilibrium raised to the power half into x2 raised to the power half. and here y2 is as it is. Now what you are going to do, this is also constant, this is also constant. Let's say this is your k dash, and this can be written as x2 raised to the power half. This is your the final rate law expression. Now if you want to calculate the order of reaction n, that will be equal to half plus 1, that is equal to 3 by 2, right? 3 by 2, that means 1.5 odd, right?
Yes.
Got it? So very simple it is. You know a specific reaction rate, that is k, it is talking about k. The rate constant is also known as velocity constant or a specific rate constant. Oh, very good. Please do this. Oh, wait a minute. Oh, let me know when you are done with this. Hmm. The rate is given at 10 seconds. Okay. Oh, with the help of this, you need to calculate 23 is D. No, it's wrong. When initial concentration of reactant is doubled in a reaction, wait a minute, its half-life period is not affected. Okay, if it is not affected, then what will be the order of reaction? I told you in the previous question it was given that T half is equal to R naught upon 2K. And this is for zero order reaction. Zero order reaction. If you are going to basically T half is directly proportional to half or half T half-life of zero order reaction is directly proportional to concentration of initial concentration of reactant. But if you are going for T half for first order reaction, it is 0.693 upon K. It doesn't depend upon the concentration. This is for first order. It doesn't depend upon the initial concentration of reactant. So A will be the answer for 23. Is that clear?
Yes, sir, clear.
22 is very easy. 22, why you didn't attempt? You need to calculate K. K is equal to what? K is equal to, you know that 2.303 upon T. And here it is not given. T is basically T2 minus T1 you can write. And then log of, here you can write final concentration upon initial concentration. So you can see uh, this is the 10 second and this is 20 seconds. So here you can write 20 and here you can write 10. And you can see the rate of first order reaction is 0.04. This is the initial one and this is the final one, right? So wait a minute. So initial concentration, what you can write, R naught will be equal to 0.04 and the finally it becomes 0.03. That means 4 by 3 it becomes, right?
Yes.
So now solve it and let me know the answer. In physical chemistry, like this chapter and electrochemistry, the calculation is not tough. Only there will be multiplication, division of the decimal. Oh, which question you are talking about?
So question number 24.
Question number 24 you are asking for 24 is also very easy. See,
It's option B, right? 1 to 8. I don't know the reason.
yes, yes, it is. Say a reaction is 50% completed in 2 hours and 75% completed in 4 hours. The order of reaction. First, you need to calculate K. After calculating K, you can get the answer. Or here, if you are going to calculate K, 75%, the time taken to complete 75%, it will come out to be double of 50%. So the answer will be 1. Can you do this or should I explain it more?
I can do it.
Okay, that's good. Good, good. Okay. Do this one. For a reaction between A and B, order with respect to A is 2 and order with respect to B is 3. The concentration of both A and B are doubled, the rate will increase by a factor. Very easy question. Let me know if you are not able to solve this. No, not B. See, I'm going to show you. Rate is equal to, you know that K into and reactant A raised to the power, let's say X, and B raised to the power, let's say 1. When you are going to read the question, you will be able to find that A, with respect to A, the order is 2, and with respect to B, the order is 3. This is the rate R. Now, R, this is, now we are going to calculate R dash, the new rate that will be equal to after doubling it. So 2A square, and here it becomes double, both are double, so 3B cube. So this becomes 2 to the 4, and 2 to the 4 to the 8 to the 32. 32 into K into A square into B whole cube. And you know this has a value R. So the new rate will be 32 times the old rate. Yes, yes. Option D. Very good. Go for the next one. Any answer for 26? This is based upon a fact that this rate constant only depends upon temperature. Only depends on temperature. For every rise of 10 degrees centigrade, K becomes double. K becomes double. So you can see 10 degrees centigrade too. You are going to up to 100 degrees centigrade. That means when you are going to 10 to 20, it was K here, now it becomes 2K. Now it becomes when 30K, 30 degrees centigrade, then it becomes 4K. Then, so it will be basically 2 raised to the power 9 times it will increase. So it becomes total of how many times? 2 raised to the power 9. What will be the scenario? 512 times. As you know that 2 to the 4 to the 8 to the 32 to the 64 to the 128 to the 256 to the 512 times. Is that clear, Shahid?
Yes, sir.
Okay. Can you change the slide?
Yes.
27D is the correct answer and 28 is E. That's good.
Sir, can you scroll up? I'll just copy it.
This much enough.
Yes, sir.
Okay, let me know. Done. Shahid,
Yes, sir. Done.
please do this. Will you be able to do this?
Yes, sir, I can. Okay.
Oh, very good. The correct answer it is. One more question I'm going to give you. Then we'll see why.
So is it correct?
Yes, D is the correct answer.
Okay.
You have done it like this, right? You can write here rate is equal to K into, basically we don't know the order. So with respect to A, let's say it is X, and with respect to B, let's say it is Y. So what I'm going to do is very simple. First, I'm going to take this second and third together, like ratio of that. So rate is given, right? So you just need to put the value of A. A is what? A is 0.3 raised to the power X. K is there, and B is having 0.2 raised to the power Y. Upon again the third equation, if you are going to see, this is your 0.3, again X K is there, and here it will be 0.4 Y. And rate is R upon R, you can write. Rate R, not R upon R. Basically, this is what I was missing. Here it is given 7.2 into 10 raised to the power minus 2 upon 2.88 into 10 raised to the power minus 1. And this will be cancelled, right? So you can calculate the value of y, right? Yes or no? Shahid?
Yes, sir.
And then you can compare with this and calculate x. So x comes out to be 1 and y comes out to be 2. So the answer is D. Go for question number 30. What is the answer for this? You can say this is your first order reaction which has a TF is equal to
Is
0.693
it
upon.
option D?
No, 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 no. If you are going to divide it now, so basically you have to be careful while calculation. So it comes out to be basically 0.00 basically k if you are going to put it here. So it will be 0.693 upon t, that is equal to 1386. So it comes out to be 0.005. So if you are going to take 5 into, so it will be minus 4. So 0.5 into 10 raised to the power minus 3, which means the answer is B. Okay.
Yes, sir.
Okay. So this is it for today, Shahid. In the next class, we will complete this. Okay.